we have two QR codes here. One's for the source code and one's for the check-in. Please make sure you do the check-in. We kind of require, it's kind of like, not required, but like we really want you to do it. And you can give us some feedback on what you think and what you want to see next. We're probably gonna wait for people a little bit longer, but we can probably go to the next slide, right? And the QR codes are still there. We're just gonna wait up a little, but it will start soon.
Okay, so meanwhile we're waiting for like 2 more minutes. We'll start at 6:05. Let's just run through the timeline of what we're gonna go through today. We're gonna give a quick intro to both clubs, UDSC and Nighthacks, which we're collabing in for this workshop. We're quickly gonna go over the project assign, kind of what we're gonna do at a very high level overview. Then we're gonna go over the WebSocket API, which we're gonna use in our program, and then the web server design. Then the Firebase design, which is going to be our database. We'll talk more about that. Then we're going to give a quick overview of Go for anybody that's not familiar with Go. And then we're going to code it. Then afterwards, we're just going to have like a quick thought experiment and just talk a little bit about what we built. Okay, we're going to start. So first, we'll just give a quick intro for GDC for any Nighthacks people that doesn't know about GDC or anybody interested. We are one subset of a larger Google-sponsored organization called Google Developers. GDC specifically meant for university students and college students all around the world. Our mission is to bridge the gap between theory and practice. So usually you'll get a lot of theory in class and it's up to you to practice it. So this is what we hope to help you with. And then it's also mainly a student-led club. So even though we like doing Google technologies, depending on what our audience wants, we can do all kinds of technologies. That's why it's really important for us to get feedback about future events that you might be interested in. And then for Nighthacks, we have Nero.
Quick introduction about Nighthacks, what we're all about. You know, you software development hackathon also. What we do only for our workshops and this Nighthacks in general, we cover technical workshops, interview prep, networking with tech companies, vendor, a mentorship project, we're building projects inside of our workshops. Need help with the project outside of the workshop on Thursdays. We have office hours on Wednesdays and Mondays sometimes. So if you join our Discord, you'll know about it. And you know, we also inform you guys about hackathon, how to get blessed there and stuff like that, all the information you know. So if you're interested in, you know, joining Nighthacks or you want some more information, you can reach out to me after and talk. But yeah, that's kind of like a quick introduction about Nighthacks.
Okay, so This is me. I'm Felipe Souza Diaz. I'm a tech lead with the Google Software Developer Club.
I'm Carlos Matias Herrero. I'm one of the other tech leads of the GDC.
So let's get started. So this is our project design. So this is what we'll be doing. So the client is like you guys. So you guys will probably have like a web browser or Google Chrome, and you guys will click on a link, and you guys will request HTTP. You guys will do an HTTP request to our server, which will give you an HTML file, which HTML is like what loads into your web browser, basically like a web page, is like the front, and that will be built into our server. And HTML files will have like some JavaScript in it. We'll run some scripts in your client side. It will be like in the client side. So it will run a WebSocket application, an instance, and that WebSocket instance will connect to our server and we'll keep track of you. So if you leave the server, it will break that connection. So we always know that, like, if you're in the server, we'll know you're there. And if you leave, we know you left. And we also have Firestore, but we're not going to worry too much about it now. But we use it to build up the HTML file that will be sent to you. So I gave like a really quick explanation of WebSocket. It's a little complicated. It's basically like a way to send information and receive at the same time. If you guys ever use a REST API, usually if you ask a REST API, it will give you an answer, and it will only answer you if you ask. But a WebSocket does not work like that. Even if you don't ask anything, can send information to you, and sometimes it can be happening at the same time. For example, here, what's happening is like ones and zeros are actually just data that's being sent to you and from the server to you. And one thing that's also differs from REST API and a WebSocket is that there's no response. For example, like a 200 response or a 400 response. You don't get to know if things went wrong. Like if things went wrong, you just see that's not working.
So I'm going to talk a bit about the Go server and how we're going to sort of structure it. So basically, even though Go isn't an object-oriented language, we should really think about our designs in terms of objects and what they do. So basically, the most intuitive object we can think of when we're designing a chat application is we need a room, we need a chat room. It's an object within itself, and it does things. And this chat room is going to receive messages from clients, and it's going to send messages to all the connected clients. We're going to use the WebSocket for that. But a big part of this is we want to talk about scalability. We can't just like when I say scalability, like I want you to think big, like you have lots of users, like hundreds of thousands of users. You can't just shove them all into a single room. That would be kind of bad. So we're not just going to teach you how to make a single chat room. We're going to teach you how to make a chat room that can be scaled to as many rooms as you want, as many rooms as you need. So that's really what scalability is. You take a small, like well-defined structure and you multiply it by however many you need it. So now this becomes a bit messy. Say that we as GDSC want to have a couple of chat rooms for announcements, just general networking, stuff like that. And then Nighthacks, for instance, wants to have a bunch of chat rooms too. We need some kind of way to separate them and organize them so we can do one more step of high level structure. And we're going to build a hub. And a hub will basically, it's another object. It contains rooms and it does stuff with those rooms. And one of the things that it does is we need a place to save our messages and retrieve them when necessary to give it to other clients that are connected to our chat room. And we're going to use Firestore for that. Firestore is going to be our database, and we'll talk a bit more about it now.
So Firebase. Firebase is Google's backend as a service software. It basically replaces the need of having a backend. It does a lot of services for us. For example, it stores data for us. It can do authentication, which we're not using it, but it could. It can do hosting, machine learning, and just a lot more. So Firebase is just the main thing, but we are focusing only in Firestore at this time. And a little bit more about Firestore. Okay, so this is how we are structuring our database. So I've been saying Firestore database, and I'm not sure if you guys are ever familiar with SQL or NoSQL databases, but this one is a NoSQL database. And the way how it works is very similar to folders and files. Basically, things are kind of organized in a very simple way, which is very beginner friendly at least, but it cannot always be the most optional, but it's very beginner friendly and very easy to mess with. So the main hub here, if we were thinking about Discord, it would be like your server. And it's called collections instead of folders, and files are like documents for Firestore. So the main hub would be a collection, and it can have a bunch of documents. And it has 3 right now: memes, general, and jokes, which those would be like your chats. And one thing that's a little bit different than folders and files is that a document can have a collection inside of it. So they all have a message collection that has all the messages. And the way how they keep track of which one is which one is by generating a random ID for each one that's unique. And every single document can have, documents can have metadata. Collections cannot. That's also one thing I should probably have mentioned. But in those messages documents, you will see that it can have some messages. For example, in that one has Philippe, the name, and hello, the message. And that's all in one string, and we're storing as a message. And it also has a timestamp, which is the date and the time that the message was sent.
So first of all, I just want to give like a quick overview of Go. And I want to mention the reason why we're using Go for this workshop. And it's not just because we're the Google Student Developer Club, but it's because Go is actually really fit for this task. Go is very, very quick, and it's best at web APIs, which is exactly what we're making, a web server. It's also really straightforward. There's this quote I really like about Go that says, there's no magic in Go. There's no like ternary operators. There's no like one-liners, if else, like there is in Python and other languages. It's very straightforward, and there's usually not more than one way to do something. So it's very easy to learn when you're coming from another language. So we're kind of going to go through the very basics. Actually, no, not the very basics. We're going to go through everything that we're going to use during this workshop. So first of all, pointers. If you don't know pointers, then I'll like give you a really quick explanation. But basically, at the top, we have a function, no hello. That's how we define a function. That's how we define parameters. We have a MSG, which is a string. And then we're just completely replacing that string with another string called world. Over by the main function, at the very top, the first 3 lines, I'm kind of giving you all the different ways you can declare variables in Go. We're going to be using the top one just because it's the fastest. But for this example, I use the third one because it's the most descriptive. So after declaring the variable str to hello world, we're going to declare a pointer. It has a star string of type, which is a pointer to a string. And then the ampersand over by the value declaration, it's basically saying, give me the address of where str is located. So if we were to print out that pointer, it would give you something like this, 0xc, like some hexadecimal value telling you where the memory address of str is. So say we run this function, no hello, and we send in str. Even though up there we replace str with the string world, it's still going to print out hello world as if nothing had changed. That's because instead of passing a pointer, we passed a value. And in a lot of languages, including Go, when you pass a value, you keep the original and you send a copy of that value. So we're not really changing anything. So basically what pointers do is we can do something like we did on the right. We change the type declaration to a pointer to a string. And then inside of the function no hello, we do star and then the variable. That basically just dereferences that variable. It says like, go to the variable you're pointing at. And then down there, you can see if we send the pointer instead, we can change to world. So that's a very basic overview of pointers.
Okay, so structs. Structs are pretty similar to C if you ever did some of that in CS1, hopefully, or maybe in another class. So you have a type, and then whatever type you want it to be. For example, here is person, and struct to make sure the thing knows it's a structure. And you can name some like parameters. I mean, some values inside of it. For example, here we have a name and an age, and the name is a string, and the age is an integer. So the way how we would declare it, it would declare to John, and we would initialize by naming those values. For example, name is John and age is 24. And then just like we can change the values of like age and name by just putting a dot to it and making equal something else. And just like we talked about pointers, it works pretty similarly. If you send a pointer version of John to a function, it will actually send the actual John. But if we send the other one on the left, we will send actually a copy of John and not really him. So any changes that were made inside the function would not reflect into the actual code.
So then we get into struct methods. If you're familiar with object-oriented programming, it's basically the same thing. This is the same code, by the way. We just added a function called getName. It's basically the same thing in object-oriented programming as if you had an object, which is a person, and then it has a method, which is getName, get me like its name. In Go, it's a bit different. You don't declare it in the same area that you declare a struct. You actually do it outside. And you can even do it in a separate file if you wanted to for whatever reason. How we do that is after the func keyword and before the name of the function, we do parentheses, whatever variable name you want to do, and then star that struct. Basically, that's saying the struct person has ownership over this function, and you cannot call this function unless you're calling it from a struct that is a person. So that's what we do down here. We have John, like we created before, and then when we get John's name, it's gonna give us John, exactly how we would expect. Then just to bring up a couple things, one thing you cannot do is if you never created John as a person, he can't get you his name. So that's what I mean by the struct person has ownership over this function. You can't call it unless you have an object of that type. And in this case, it would throw a panic. In Go, when you throw an exception, it's not called an exception or error. It's usually called a panic. It just panics and shuts down and screams at you. Next one.
Okay, anonymous functions. This one is a little complicated, but let's see if we can do this. So if you are familiar with JavaScript, you might be aware that you can do functions with no name. And we did one here. So the variable A is storing a function that doesn't have a name, but it does have a parameter. So it has a string parameter, and all it's really doing is printing. And we are storing that function to a variable. And to run it, we would just use the variable, parentheses, and whatever string. Or we would have to fill in those parameters. If they were different, we would have to have different stuff as well. And one thing that makes them really, really special is that, for example, here, we can have a function that takes in a function. And we can run that whatever function is. For example, here is run this, and it's taking a parameter of handler, which is a function that takes in a string. And handler is whatever handler is running with hello. And in the main function down there, we see we define A again, is the same function. And we throw A inside this run this, and all it will really do is just print hello, because that's what A does.
Okay, so for this workshop, we're going to code using Replit. We've used it in our workshops before. And feel free to open it up and create an account if you haven't already. And we're going to create, we're going to give you a couple of minutes to just create an account if you haven't. Create a new Replit using Go. Name your replit however you want for this. I'm just gonna do mini Discord. And we're just gonna start with an empty Go project. I'll just give like 2 more minutes just to make sure. Oh, by the way, we have this room reserved until 8. We're gonna try to get it under an hour and a half. Feel free to come and go as needed. We'll put up the recording also. Okay. In 1 more minute, we'll start. Let me know anybody if you're like having trouble getting Replit up and working. Yeah. Yeah, it's an online IDE. The one drawback is that your code is like public, like everybody can see it. That's the only drawback. But that shouldn't matter too much for this workshop. Yeah. If you also have Go installed locally, feel free to follow along. But we'll like try to do everything through Replit. Okay, we can start then. So we're gonna start with making an index file. And Philippe is now gonna take over and we're gonna sort of create the basic look of our website first.
Okay. So we are creating this HTML file, and to start HTML file, you got to start with the HTML tag, just to make sure it knows it's HTML. So we have a head, which is usually where metadata goes in. So let me close this. Nice. So in the head, you usually have metadata, which is basically like things that don't really affect the website. For example, this would be like a title or something that like it would affect like the top of the website when we have a hosting, I will point it out. So the title will be chat app. Yeah. Now, every HTML file has a head and a body. Well, and body is where most of the data will go in. Oops. So in the body, we're gonna have a center tag, which is just to center things. It's basically like a div, but centered. And then here we'll have what is it? Info or a table? Oh, okay. It's okay. So it's a pre-tag. So this is basically a paragraph tag, but it's not. It's like a paragraph tag that has no no styling to it. So whatever you write, it will just be the same style you wrote. And for now, we will just leave it like this. So it's just an empty text box basically. And we're gonna have some input tags. And this will be basically be like where you will input your message. Oh wait. Okay. Right. So input tag. So input tag is just an empty box where you can type in, and we can do some things. We can have a placeholder where it will display some text, like the usually lets you know what information will go inside this. And for us, this will be like name, like your name. Or I think we have like fancy name in our thing, but we can go with name. We give it an ID of username just so we can tag in after with JavaScript. And we also need to like choose a type for it, so it knows it's a type string. Okay, so we're gonna have to do this again for messages. So I'm just gonna copy this. And this would be an input box for your message. Oh wait, I think this is supposed to be text, right? Yeah. I think types are weird. I think it's text. It's just basically string. And I think there's autocomplete. I'm not quite sure why this is a thing, but we gotta turn it off. And let's just turn this off. I'm really unsure of what this is, but
It just kept filling it with like my previous usernames. But
oh, okay.
there's
So it's like
more optional.
recommendations of what you type before. Yeah. And once you have your messages, what do you need? Oh yeah, we will have multiple chats. So I guess we need like a button for every chat. Like if you want to go through the main, if you want to go through general or jokes or whatever chat you're going to. And for now, let's just write this as general. These buttons will be all the same. So I would just, oh wait, let me give them ID. So we'll have like 3 chats for now. Well, no, for the entire thing, but we could have more if we wanted. So jokes and memes. Oh yeah, let me say join memes. Okay. The idea would be, I don't know, is this button to it? No. Jokes. But yeah. So this is this is as I was talking about. This is basically like a text box, and this will be eventually our app. So I would just add a tag of chat, and we can also style it a little bit because everything else can look kind of weird, but it would be hard to look through everything if we don't style this box. So let's write some style for it, because this is just like 3 buttons, like very simply, like very simple buttons, and a placeholder, which is also very simple. But the text box, the chat box, we might want to style a little bit. So want to do text align, just makes things on the left. I mean, we're making things on the left. Did I spell this right now? Yeah. Did I spell that right again? Yeah. English is not my first language. Yeah. A background color. A background color of whatever we want, and we want gray. I think a text color. I think text will already be black. With what are we using? We're using pixels. We can use a WH, which is ooh. I don't remember. Well, let's stick with pixels. So I'm in height, just to make sure it's not like invisible, because if you have nothing inside of first, it will be invisible. So we want to add like a minimum height for it. Oh wait, I'm doing with equals. You're supposed to use 2 dots. Sorry. That's why it was being read. Wait, we didn't know now. 500 pixels. Also, overflow. Overflow is just if things go, like, to keep things inside of it. We want to set the overflow to auto, so things never go outside our height. But we can also set this as scroll, and you have like a scroll, and you can scroll with it when it overflows. But this is like the very basic HTML page. It doesn't have much with it yet, but we eventually add a script tag that will actually create the WebSocket. But for now, I think this is enough, right? Yeah.
Yeah, just one quick thing before we move on. In the style, we're gonna attach this to the chat tag.
Oopsie. Yeah.
So what this means is everything that we're doing, we're applying it just to this chat PRE right here, this paragraph. Okay, yeah, let's start writing some Golang. Oh, let me know if everybody's ready to move on or not. If anybody needs to wait a little more, let me know. So for Golang, we're gonna use a couple libraries. The first one that we're gonna use is it's called Gin. We can put the import statement github.com gin gonic and then /gin. So one of the cool things about Golang is it has this module system that kind of handles all your dependencies in a pretty nice manner. In our case, if we wait enough, Replit is going to import it for us. But in reality, you can use either the console or the shell. And if you hover over it, it's going to tell you could not import just because it doesn't know if it has it. We can run go mod tidy. And what that's going to do is it's going to go ahead, find that package, download all the dependencies that it needs, and kind of set it up for us. If you wait long enough, Replit's like just going to take care of it, but you should probably do it this way. So now if you hover over it again, it still could not import for whatever reason. This is okay. Let's try to use it, see what happens. So one of the first things we need to do, we need to serve this HTML file so that when somebody opens the browser to our page, they can basically get that index file and see what we just built. So one of the ways to do that is you set up a router. There we go. You set up a router, and the way we're going to do that, as you can see, the errors went away, so Replit finally understood that that's a new dependency. We're going to call gen, and we're going to create a default router. So basically, the router is what takes care of registering like URLs. So when, say, we have our website and we go to, what we want to do is when somebody goes to our website and specifically like loads up the page, you're going to have like an empty dash here. We want that to give them the HTML file that we just created. So that's what we're going to do. We're going to go to the router and we're going to register a GET request, basically, and say whenever you just go to the home page, it's a dash, like it just automatically, there's a dash. You're going to do something. And if we hover over this GET right here, if Replit isn't being annoying. Okay, it is. So basically what happens here is we need a handler function. We need to tell it, hey, like, this is what we want you to do when we receive this dash. And what we want to do is serve the HTML file. So here's what we're going to do. We talked about anonymous functions before, so this is the first time we're going to use one. Let's just create one called handler. And we're going to create a function. That function is going to take a gin context. Whoa. It's going to take a gin dot context. If I can type. Okay. So basically, when we give this function to gin, it's going to just run it and give it a context. The context contains basically all the information about the client that's trying to contact your server, including what URL they're trying to go to, and a bunch of other things. In our case, we're going to use a standard library built in Go called HTTP. It's one of Go's many extensive libraries that are that make it really useful for being a web server. And when we call HTTP, we're going to say, serve me this file. And like I said, it auto-imported it. Like I said, we want to give them the HTML file. So we're going to give them the index.html. And now we also need to give them, right before it, we need to give it the context writer and the context reader. Or sorry, the context request. Okay, so now our handler function is done. You'll see that there's no more errors. There's like a lot more that about this context. Let's see if we can hover over it. Okay, yeah. So in behind the scenes, Jin is doing this context thing and it's giving it to us, and it contains a lot of things. Parameters, more handlers, engine, like a bunch of really useful stuff. But we really only care about the writer and the request. This is what's going to let our Go server send this index file and basically just do whatever we want it to do. Let me erase this since we're not using it. Okay. Also, one of the really cool things about Go is it auto formats your code. If you're using Replit or if you're using anything and you have some weird indentation, you can click over here, format, and it'll actually auto format your code, which is really cool. But anyways, so we created a get, like a get path, a get request, and we are telling it to use this handler, which is going to serve our file. So the next step is we're going to go to that router and we're going to run it. And we're going to run it in, let's just say, port 8080 of Replit's computer thing. Let me just clear this on the right side. So at this point, if we I'm not a big fan of this run button. It actually, sometimes it doesn't work as expected. So I'm just gonna do it manually. In Go, you just say go run, and then the file that you want to run. So if we run this file and give it a second, this is basically going to spin up a server that's handling requests to like the local host of whatever replit is hosting it at port 8080. And if we ask for a slash, which is basically just the actual website, it's going to do this. It's going to serve us that file. So let's just give it a second because replit takes a bit sometime. Okay, I'm going to cancel that and I'm going to click run. Okay. If it loaded for you guys, well, you'll basically see this is sometimes a little messy, so I like opening in a new tab. And okay, so the index file is a little messed up, but we have the name, we have here we will type our username, we'll type our message, and here we can join various different rooms. This isn't the prettiest front. You can style it however you want. We're really going to focus on the back end that makes all this work. Let's see what's missing from the index file. Yeah, maybe. Let me just go to our source code in the beginning. Okay, text line left. Okay, so we don't need, we shouldn't need these quotes. Hopefully, we'll see. Turn on your pixels. 100. Padding. Actually, let me add a padding tag. This isn't really necessary, but it's just kind of nice. And then. Like I. Okay, let me just double check really quickly. Okay, this should work, so let's try to run it again. And open a new tab. Okay, we have a pretty great chat, but it's a chat. It works. It works as a front for what we're gonna do, and we're gonna start writing the actual like the rest of the business logic that actually handles the requests and all that kind of stuff. Yeah, let's do that. Okay, so here's what we're gonna do. We're going to add a folder. We're gonna call it chat. Inside of this folder, I'm gonna have all the files that create our hubs, create our rooms, and sort of interacts with the database. For right now, let's focus on, I'm gonna create a thingy called hub.go. I'm also gonna create another file called room.go. And here's where we're gonna define the, we can stop this. Here's where we're gonna define all the structs that are gonna basically take care of all the messages and all the logic and everything. So the way Go file works in Go, you have a package that it's a part of. I'm gonna call this package chat because we have it under the chat folder. That's really, there's no more explanation I'm like going to give. Then we have stuff inside of it. We're also gonna name this package chat. And I'll start with the room. I'll start with like the lowest level and work ourselves up to the higher levels of the rooms and then the hubs. Anything? Okay, so what I'm gonna do first, I'm not gonna start writing out the logic that handles all this. Right now, I'm gonna create the structs. Let's call this struct room. And we're gonna define all the structs that we need, and then we're gonna start writing the actual code. So every room is going to have a name. I want every room to have a name, and so we can differentiate between them. And we are also going to use a melody. Melody is going to be another library that we're going to use today. And melody kind of takes care of the WebSockets, so we don't have to deal with all the lower level interchanges that happens with the socket. It's kind of like a nice API abstraction that just lets us send and receive messages. So we're going to import it again, like we did before, github.com/ this one's OLAHOL, and it's called melody. Here again, I'm going to do go mod tidy. And as you can see, it's going to go find the module package melody. And it downloaded it. It's a pretty light package. So we're going to have a melody in every room. Like I said, the melody in every room is going to take care of handling the WebSocket messages. So the melody is going to have a type pointer to melody.melody. This first melody is like using this package, just like when we can call chat. We'll call chat over in main.go. So that's the same thing. We're calling melody in this Go file that we imported, and then we're calling a melody struct whenever Replit wants to realize what we're doing. We'll leave that there for a couple minutes and we'll see. And that's all I'm going to have for now for the room. And I actually want to go to like a lower step. We're going to say, we're going to have a message struct. This message struct is going to take care of, it's sort of just going to be like what a message is to us. So to us, a message is going to have a timestamp so that we know exactly what time we received it and what time it was received. For this, we're going to use the standard library time, and we're going to use a time struct. It auto-imported it. A time struct, again, usually these library structs are like huge and has a lot of stuff. But it basically has a timestamp recognizable by Go. And then we're also going to have the content of this message, which is going to be of type string. So a quick example of message is going to be something like whoever the user was that sent it, then the content, and then over here all the way to the left is going to have a timestamp. It can be anything like, yeah, it can be like that, and then a time that it was sent. So this is what like a complete message would look like. And here we have the timestamp, and then we have the actual content. That's how we're going to separate it. Okay, so we basically have the rooms created as structs, and then we're going to go over to the hub, and let's create the sort of the high-level hub structure. This hub is going to have, we're going to create a hub struct, and it's going to have a name. I also want the hubs to have a name. Similar to how Discord works with Discord servers, they have a name, and then all the different channels. For us, those would be rooms. So what I wanted the hub, I want to keep I want to be aware of all the rooms that a hub contains. So the way we're going to do that is we're actually going to have a map. This is how you declare a map in Go. We're going to have a map. The key is going to be a string, and it's going to lead us to a pointer to a room struct. Oh, another thing about Go, as long as files are within the same package, they have access to structs created outside of this own file. So we're calling this room struct that has a name and a melody, even though it was created in this other file. Yeah, so this is what a hub is going to have. Yeah, let's just do that for now. Okay. So what we're going to do is this hub also needs, actually, no, I'm not going to do that yet. let's go over to the room and let's actually start implementing the room. So what we're going to do is this. We're going to create the business logic for the room. First, I'm going to create a struct method for this message, struct. And remember, the way we do that is we do this parentheses thing. This is going to say toString. The function name is toString, and it's going to be a method for this message struct. I'm sort of just using this as a way to say sort of take the time, take the content, put it all into a singular string, which would look exactly like this. And we're going to use that to send it over to clients. So let's do that by creating a time variable. This time variable is going to be m.timestamp. And this works because m is the struct that this function will be called on in the future, and we're accessing the timestamp field. And in Go, you can take a timestamp and you can click format, and you can have your own custom format. And that's what we're going to have actually. So toString will receive a parameter, which is going to be a string. And then we're going to take the content. Same way, we're just going to say m.content, and we're going to return time plus just a space and the content. So, oh yeah, we also need to define what we're going to return. We do that right here at the end of the function signature. We say string, so we're going to return a string. So this will literally return this. This is what we want. Okay, now we get to the fancy logic. So we're going to create a new function. This one, it's going to be a struct method for the room itself, for the room struct. And this is going to be, we're going to call it new message handler. This new message handler is going to take a melody session, and it's going to take data. This data is going to be of type, it's going to be an array of bytes. This is how we declare that type in Go. We just have an array of bytes, and Go is able to understand that. So we're actually, even though we're going to receive this parameter, we're not going to use it. So we're just going to do an underscore, and in a lot of languages, this is just how you ignore a variable. Okay, so basically, when we receive a message, this is the function that's going to handle what it does with that message. So what we want to do is we want to create a new message struct. And this is how we're going to do it. How we showed on the slides before. We just create a new message struct, and we say the timestamp is going to be time.now, and the content is going to be this data that we received, but I want to turn it into a string. I don't want it to just be an array of bytes. So we just typecast it. This is how we do it in Go. And boom, just typecast it to a string. So just to be clear, this function is what is going to receive the data from a client, from a WebSocket, and it's going to create a message struct, and then it's going to send that message to all the other connected clients. How we're going to do that is we're going to go to the room, to R. We're going to go to its melody, and we're going to use a function called broadcast. And this broadcast function, see if it loads. This is still not importing. Okay. So this broadcast function is basically going to take whatever data you give it and send it to every connected client that's connected through a WebSocket. Now this data is going to be a array bytes. That's the kind of data that this function wants. So we can actually just send it this data we received. So I know that we aren't using this right now, and that's fine. We are going to use it later. So I'm actually going to just do this. This is do an underscore. You can comment it out actually, but this is really important to have because we're going to use it later. So, okay, that's the message handler. And then that's actually all we need for this room struct. Let's see if this is still not loading. Really weird. Okay. Yeah, so then we're gonna go to the hub. Our room is basically done for now. The lowest implementation we could make. It's done, and we're gonna go over to the hub, and we're going to make some functions for it. We're gonna do some struct methods again. So these functions are specific to the hub. We're gonna create a new hub. It's going to take a name. We want to give the hub a name whenever we call this function. And it's going to return a pointer to a newly created hub. So all we do is we do hub equal to, we've done this before, it's just going to be, we initialize a new hub and we say your name field, like we have up here, is equal to whatever name got sent over, comma, and then we're gonna initialize your rooms. In other languages, you can just be like new map. In Go, what we do is we call the make function, and we make a map of strings to room, and we return hub. Okay, so this is basically just initializing a new hub for when we call it over in main. And now we're also going to add a room. This is where everything kind of starts connecting. We're gonna create another struct method for the hub, and we're gonna say your function add room. We want a name for this room. Oh, not a name, but a name. And we're also going to return a newly created room. So we're going to do basically the same thing we did up here. We're going to create a new room. We're going to create a new room. We're going to give it a name. It's going to be the name that we were given up here. And then we're going to, here's where we initialize the melody. So we say your field that's a melody is going to be melody.new. Let's see, melody is still having trouble being imported. Okay, it was imported here. So let's just go up here and import it manually too. github.com/ let's copy the melody that we have. Okay, so after all this work, we basically have a function that can create a new room, a new hub, and then when we have this new hub, we're going to add rooms to it. And here's where it comes together. We go to this hub that we're adding a room to. We're going to its rooms. It's a hash map, so we're just going to access it with the name that it was given that we have. And then we're going to say you are equal to this room. So we're basically just adding the room to the hash map, this map over here. So we have a count of all the rooms that we created. And we're going to access this room, and we're going to say melody dot handle message. And we're going to go to that room and say, give me a new message handler. And then we can just return this room, this room. Okay, so this might look a little weird. This is basically what we did before. It's not an anonymous function, but it's a function that we created over in rooms. Can I like split? Oh yeah, I can. Okay. We created this function over in rooms, and this function takes whatever data it received and it broadcasts it to all the clients. And we're basically telling Melody, whenever you have a new message, handle it using this function, which is this one right here. So, okay. So everything should be good. Now we can go over to, oh, we're missing one big part, which is kind of confusing, but we'll just power through. We need to add another function to this hub. It's going to be called register. We're basically going to take a router, the same kind of router that we created over in main. A router is actually a GIN engine type. And okay, you got GIN also. Okay. So remember how over in main, we created this .get, and we told it whenever you get a slash, like just the home page, run this function. We need to do the same thing, but for every hub that we create. For every hub that we create, we want to say, whenever you go to our website, and you give a hub name, in our case, we're just gonna always have it as main or main hub. We also, basically, this is gonna be the hub name, and this is gonna be the room name. We need to register another section of that router that can handle this, so that we can serve this like WebSocket that we're dealing with. So how we do that is we actually do another router.get thing. Except now we need this. We need like this last part. Just like before we had the slash, this is going to be slash whatever the hub's name is. So like up here, slash whatever the hub name is. And then we're gonna do this thing. If you're not familiar with URL parameters, this might seem a little weird. But basically this colon is saying whatever is put over here, whatever is put over here, and it can literally be whatever the client puts, this is going to be a variable that we can extract later. And that's actually exactly what we're going to do. We're going to, remember how we had an anonymous function here, the handler, and we used it? This might seem weird, but I'm just going to declare it right here. I'm not going to make it a separate variable. This is very common in Go, where you declare your anonymous functions right on the parameter that you're calling it in. So, okay, so we're going to create a new function. It's going to take a GIN context. And now we're going to extract this room ID that would be over here. And we're going to do that by just creating a new variable. And we're going to say context.params. Nope, not params. Param. Give me this parameter that I declared here, the room ID. So now we have this room ID. So it means that whenever somebody goes to our website and tries to go into a URL like this, we're going to take this room ID that we just extracted, and we're going to say, does this room even exist? The way we do that in Go is we're going to create two variables. It's going to be room and OK. And we're going to say this hub that we're in right now, give me all the rooms. Find me this like room ID that that the person is trying to go to. Yeah. So in Go, what this will do is it'll give you the room, and it will also give you an OK variable. And if you're not OK, it means this room doesn't exist. So we can just say log println. We're just gonna say room doesn't exist. And then we're just gonna return early and not tell whoever the client was anything. I just clicked save really quickly and didn't mean to run that. Okay. And so now we need a way to say we did get the room and say the room does exist. What are we going to do? We're going to say room.melody, take that room's melody, and handle this new request. Handle request. And we're going to do the same thing we did before. We're just going to give it the context writer and the context request. Not the copy. Okay. And at this point, Melody is going to, let me import log for whatever reason it's not here. Okay. Forget about the log, we're just gonna return. Okay, so even though this might look a little confusing, we're basically just extracting this room ID for whatever hub where the user is going to, and we're checking if it exists in our rooms, and if it does, we're telling Melody, go handle this request, handle the WebSocket. I don't want to deal with it, you can do it. Okay, so we have the register, we have the new hub, we have the add room. Okay, this is your time. So, oh, sorry, 1 second. Let me create. Let's create a new hub over by main. We're gonna call this the main hub. And how we're gonna do that is we're gonna call the, okay, so if you go over to your go.mod file, every module, that's what this whole thing is. We can call this a module. Every module has a name. This one's main. I'm gonna call it mini Discord because I think that's a horrible name for Replit to give it. And this allows us to import from our main. We have a package main and we have a package chat. This allows us to import whatever is in this chat, which are these two files. So we're going to go over here. We're going to go to the main hub. We're going to say mini discord dot chat. Oh, no, apologies. We're going to actually do this. We're going to import mini discord /chat. And now we have access to everything that's within this chat. So we can say chat dot new hub whenever this feels like loading. Okay. And we're going to call this function. We're going to call the new hub that we created before, and we're going to call it main hub. And we're going to add rooms to it. We're going to add a general room, chat dot add room. Let's call it general. And let's do this 2 more times. We're going to get jokes, and we're going to get memes. Okay, so now we have a hub created and 3 rooms. And we're almost done with this part. Yeah, and now we're gonna run it. And we're not really using these at the moment, so we can actually just, might seem a little weird, but I guess go with complaining. Yeah, so we're creating a new hub called main hub, and we're adding rooms to, oh no, apologies. That's not right. We're going to add rooms to this main hub. And then we don't really have to store these rooms. We can just ignore them. Okay, so we created a hub and we added rooms to it. Now we can actually run this whenever this comes. Yeah, Replic's being weird with these endpoints. This one finally loaded. Okay, this one finally loaded. So now we can actually run this. And see chat.new hub. New hub. We input a chat. Package chat, package chat. Oh yeah, sorry about this. The new hub that we created, it actually shouldn't be part of it shouldn't be part of the hub, since we remember that, like, when I do this, hub calls ownership of this function. So I can't create a new hub if I can't have a hub and then create a new one. I need to be able to do it from scratch. So that should work now. Okay, so drum roll. Nothing will happen because we still need to have the scripts that create the WebSocket. So that's what Felipe is going to do now. But now all the backend is ready and set up to receive messages and send them. Yeah.
Okay. Okay, so we're gonna go back to our index file. Wait, where were we? Oh, yeah. So remember when I said that we would have run some scripts on the client side, which is basically a script on this index HTML file. So we're gonna have a script tag, and we're gonna run some JavaScript on your file. I think the first thing we will do is get all the elements we created. For example, we'll get the username box. And you do by just writing document dot get element by ID. Oh, by ID. And then you write the ID that we wrote, and for here we have username.
You can scroll down a bit. So
And so we'll do a lot of times for each of the elements we created. Oops. I'm not sure if we created that many, but so text. This message box. Chat box will be the chat. General button. And we'll have a joke button. And also a memes button for every button that we created. And we'll target them with their IDs as well. Now that we target all them, oh wait, those are supposed to. I did this in Replit. So now we will initialize the current room as as general. So you start in the general chat. And we'll create a just a link to our WebSocket. So this is just a URL that, to make sure that you're connecting to us, to our server. So I would like to add a comment here. Is that let me finish this first. That's all right. So what this is basically doing is that whatever is the link or the website that we're using to host the main thing, we're gonna use it, and then we're gonna set to main, which for now main's like the only server that we only have main hub, so it's gonna be the only one. So we have this WebSocket. That's what WS stands for, WebSocket. And if you're running this with Replit, you will need to change to SS, and the extra S means it's secure. It's basically what it means. And because we're running with Replit, it's going to run up in an instance that's HTTPS, which means it's secure. And they only accept secure WebSockets, so we will have to add an extra S here. And this is basically a link to connect to our WebSocket. That's what this mainly is. And once we're creating our WebSocket, we will use it. So if we're also gonna make sure that if you haven't chosen a name, you have just anonymous. So this will be like your name, because we require a name to create a to send the message. To build the message, we require a name. Yeah. So when you create a WebSocket, it requires you to have a few handler functions. And we're going to create them now, but we can actually start with the WebSocket, and then we just go with them as we go. So WebSocket, new room. So every room will have their own WebSocket, because we don't want people messaging in general and you receiving it in like another chat. So okay. So this is gonna be anonymous function. We don't have a name for it, but we do have parameters, and this are gonna be them. So the URL hub is what we created. It's just to make sure, and the new room will probably be like a name. And in JavaScript, you have to have this arrow for anonymous functions. And if you are currently in a chat, we need to close that connection and open a new one in the new chat that you will be in. Okay. So current room will be this new room that we're taking as a parameter. This will be like the name of the room that we join in. And then we will have the URL, which we will build up, and it will hub URL plus the name of the room. So there's like a string. And then we'll actually create the WebSocket. And we'll create the WebSocket with the URL that we created right here. And this WebSocket, again, will require some functions. For now, when it opens, it has to do something. When it closes, it has to do something. So these are like default functions that it has, but it has no property to it, so we have to assign them. on message. So now we're going to create those functions that we will have true assigned. So constant socket close. So when the WebSocket is closed, we want to make sure you know you're disconnected. So we're going to create a line. Oh, okay. Data is disconnected. And a new line. Because our chat box is going to be basically like one big string. So we got to make sure we don't keep everything in the same line. And we will add that to our chat box. And a chat box element, because it's a pre-tag, which is basically it's basically a p tag, so it's basically like a way to store strings. It should have some inner text. So we can target that by writing this inner text, and then we can add that line that we created to it. And we're going to create a very similar function to this. That will be when you open it. So when you open our website for the first time, we also got to let you know that you're connected to it. Let us connect. So we're gonna name which room you got connected to. So this requires us like room from us, from you. Oh wait. Oh, it would not require room. Yeah. I think it will have it because it's gonna be like right here. So because it's inside of our end. Wait, am I creating this? Oh, this is supposed to be outside. Sorry. I think this looks good. And we got to do one for, oh. So we got to make one for when a message is sent. So I can message. It will take in a string. A line. So we're just adding this to our chat box. So it's the message data plus like a new line because everything is like in one single string. And we're adding that to our chat box. So every time a message is received, it will add to the chat box. This looks good. Let's see. So now we can use them here. Okay. And we can return the whole thing now. So this will just create this WebSocket instance, and we'll set some of its properties, some functions that we defined, and it will return the whole thing. Oops. Just making sure I don't miss any semicolons. Okay. Alright, so if you want to run this on localhost, just to make sure I let you guys know, this will not run in localhost because it's only runs in secure connections, and you will need to just change like this to 1S, not 2. So it would be like this if you wanted to run locally. So if you're not using a greplet, you probably want to do it like this. Then you will use a go run main.go. And that will spin up a version in your localhost, and it will mess you up if you have 2S's because your localhost is not secure. Yeah. So now, so we got to create some instance of WebSocket, and these are some of the parameters that we require. Let's do it. All right, so WebSocket equal. Socket new. Oh my god. It will take in a null because we make a new one. Or if you do have one, it will close it and then open a new one. But this is when you connect to it. When you connect to it, you won't have one, so there's nothing to close. So now we kind of have our main hub working. This WebSocket connection is working. So when you send a message to the WebSocket, it will go through, and Melody will send you the string to you. And when you receive the message, JavaScript will add to the chat box with a new line. And this will work for the general chat, but we want to add the functionality of clicking those buttons and actually going to different.
The general first.
Yeah.
Let's see it working first.
Let's see if it works. Did you run the code, or did you just click run?
I clicked run because I wasn't working.
Yeah. I'll give a few more seconds, but if it doesn't, I will also click run.
It's really slow.
Yeah, I'm not quite sure why. Okay. I'll just see to break out of this, and let me see if this works. Okay.
Oh, yeah. If you go back, if you go up, we called it main hub instead of main. Sorry about that. Other way, yeah. Instead
Oh,
of main.
main hub.
Yeah.
Is it like with capital?
Yeah. Yeah, like that.
Is it, where'd you create it? Like in main?
In main.
Oh, okay. I see. Sorry. Yep. All right, let's try running this again. This is, oh, am I missing some column somewhere? Oh,
No, the request is getting made. The main,
Main?
main.go.
Yeah. Right, let me see if I think main's good. Is it really gonna break?
It might be in my go. The code's fine. It's probably in my go file.
I don't know. Yeah, you can take a look at it.
Let me quickly skim over the Go file. Seems like there's something wrong. Just. Oops.
Yeah.
Oh yeah. So we created the register function, but we never called it. Sorry about that. We're gonna have to call it in this new hub function. So we're just gonna, we created the new hub here, so we're just gonna call this register function. And this new hub also needs the router. So we're gonna send this router, and over in Go, whenever we call this new hub, we're gonna send the router that we have. So we're just passing the router around. So when we create a new hub, we'll send the router in and we'll register it in the router. Okay, so let me try this again. Okay. So when I run this, okay, so it seems to be working. We just need to add the functionality of like sending a message, like when you click enter in the index file.
Yeah.
So we just need to do that. But it seems to be working.
Nice. Okay, so now we gotta get those buttons to work, and so we targeted the buttons here. So we have
The message box, the username box in the message box.
oh yeah. Oops. Alright, so message box on key down. Let me open this up just to make sure I don't miss anything. On key down, run a function. Event, which event would be the key down. Is it like this? Or okay. So if you press enter in your keyboard, or where is it? Okay. And if you have like something in the string, if your message is nothing, we won't send nothing. So as long as there's something there, then it's not empty. Hmm?
Event.
Oh. Sorry. Oops. So what an NB?
Message box dot value. Like if the message box is empty.
What do you mean?
like instead of event.value, it's message box.value.
Oh, okay.
Sorry.
Sorry. Oopsie. So would it here be like message box? Oh wait, this would be name equal user name box dot value.
Mhm.
And then we're getting just the name of whatever you input in your name box. And we also gotta get we also disable the user box once you have a name. So you cannot change it, but I think it's okay. You get to select your name once and you're stuck with it. So the message box, we get it again, and then it will also disable. Oh. Let's spell it wrong. No. Oh, we also will reset it, not disable, sorry. Oh, this is focus function does again?
It like focuses your pointer to, like when you click enter in the username box, it goes to the message box there.
Oh, okay.
Um,
Is this right?
okay.
Oh wait, I think I messed up. I think this is okay. I see what I did wrong. I think this is the reason why I was writing name because I think I was doing like the name one, then not that one. So I think this is a little different. I think we're not gonna do this yet. This is for the name when you're doing the name function, not the message function, right? Oh.
You can change. I think you can change message box to username box. Like, I think that's what we're doing right now.
Yeah, yeah. But I think it'll be fine. I think you can just write because we're using the WebSocket and this is pretty short. Because we just send in the script through like whatever message it is.
Yeah.
Okay. So this is what we're actually sending. Oh, sorry. Oh, your whatever name you have. This is what we name. Okay, so your name will start anonymous. So this would be just brackets and anonymous, and plus your message and a space, and then your message. The message value would be whatever you wrote there, and then we'll empty the message box. Now we can do the other one. This is good. Let me see though. Now I can do the username one. The username box dot on key down equal function. And doing if event a key. So if you press enter again, and name. Oh. So we would have choose name value because we want to eventually add to like change the name value, right? So for now it would be like anonymous. So I think as long as it's not empty, we can change it from anonymous. But if we don't want to change, if it's not empty. Name would be equal. Oh wait, this would be username. Right. Sorry. This would be like if your name is empty, then it won't replace the anonymous name that we have. General, like I said, disabled, you only get to choose your name once. the message box will be the only thing you have. Oh. And we'll focus, we will change you will be typing in message box instead of the name. Okay. Let me see if I messed up something. I think it looks good. Oh, missing some columns. Let me see. Okay, so now we actually got to do. I think we can send messages now.
Yeah, we should try that.
We should try that, and then I mess up with the joke buttons. We do it by clicking around.
Okay.
It seems like the website is not connecting. Let me see. Websocket.
If you can open the site and click F12.
What?
If you can click F12, we can see.
Mhm.
F12.
That's all.
You can go into console.
Yeah.
Okay. There's no errors.
Let me run again. It seems like
Okay, there we go. So it loaded into general.
Huh?
You want to check the function that writes to
the function that writes this one.
if
General.
you,
Oh wait. Okay. No, I do have the camera for general.
yeah, it loaded into general. It just, if you go over to the chat again, if you like highlight that box, is it written? Just we can't see it right now.
I don't think so. I can write the text, change the text color. Is it like text?
Need to rerun it.
Yeah. It doesn't seem like it is. Fingers crossed. Okay. That's weird. Let me see what did I get wrong. What is the camera? That's fine.
Try using a username and then the message box, see if it sends anything.
Okay. Okay.
Okay,
Close.
already closing or closed it. Okay, the Websocket. Oh, can you refresh the page? Like the chat one. Yeah.
Like
Like the one you were just at before. Yeah, like click on the
oh, okay.
refresh it. Okay.
Refresh, yeah.
See if the Websocket's still active.
Oh.
Oh,
It is
okay.
active, it's just why is it not printing?
showcase like multiple tabs and sending messages and stuff.
All right. How do you like remove this overlay on top?
I have no idea.
Can I grab them like this? Are they? Okay. I don't know. I'm not quite sure how to do this.
I can try if you want.
Yeah.
Yeah.
It seems like something is breaking down.
Okay, so we have the WebSockets connected, and let's split this into multiple things. Okay. So let's just refresh both these pages so the WebSocket connection can like activate and see what happens.
I think we're not storing any messages, so whatever you send won't be stored, but
There we go.
hopefully. Okay. Nice.
Magic. You can get it in both clients. So WebSocket is sending the data and it's receiving it in both clients that are connected. Right now we have it in the same computer. If this was like hosted publicly, you can like as many people as are connected are going to receive it. Do you want to do it like that?
Yeah.
It's oh, okay. So just so we don't leave you hanging, we are going to go to okay. We have a live demo that you can all try this at. So if you go to the website, you can log in, put a username, start texting each other. Should work. Or scan the QR. Oop, sorry about that. Let me just like separate this.
Also, if you were following along and you found a bug, we probably better at solving those than trying to find a bunch of live coding.
Yeah.
So
let me know
if you
you're
have
able
any
to.
bugs, please let us know. We can probably figure out what was happening.
Okay. To check that that's actually working. Okay. Okay. Let me know if there's an issue with it. Like, let me know if you guys can send messages or not through it.
Let me try.
Oh, there you go. Awesome. And this has fully implemented like the different rooms, so you can switch from them. Yeah, we do apologize if it just ran a little long. We do have the source code available, and we posted it in Discord too. So you're more than welcome to like go check it out, the entire code.
Yeah,
Awesome.
it seems like we're not gonna get to the Firestore part. Sorry about that, but we can.
We'll post instructions and like a guide in our Discord too.
Yeah. So
Sorry about that.
we can. Yeah. Our Discord.
It's funny.
I also have a.
Oh, never mind.
Without the S.
Yeah, without the S. Sorry about that. Okay. Yep. Yeah. Like the one on the right or like on the left? Yeah. Actually, I'm just going to. Okay. Yep.
Yeah, I think we can like walk over what we have coded and explain what it does, and probably show you guys what you guys will be missing if you guys like do download the source code. Because do you have a Firebase, like the console, open?
Oh yeah, let me show you guys. Okay, so the live demo is being stored in Firebase. So all your messages are being stored in my Firebase. So yeah. Firebase. This has the entire like implementation. So if we go to my Firebase and we go to the console, mini Discord.
We should show like how to get the secret, just so they can run it as well.
Well, we could. This is like not like even set up for it right now. So in my Firebase, we have the structure that we went over in the slides. We have the main hub with general and all of our chats. And yeah, so this is how it would look if you implemented Firebase. You'd have a bunch of, like we went over, these are collections that have documents, and then documents have collections within them that have documents within them. And you kind of store all the messages. And this is mainly used in the application whenever a new user logs into a room to give them all the previous messages, like the message history. That's really what we're using it for.
Yeah, because like we can send the messages even without storing them. For example, as you guys can see, you guys can send a bunch of messages, but we're not really. I mean, we send a bunch of messages. The message that you guys are sending are being stored because it's in a live demo. But the message that we did in our localhost right there, they wouldn't be stored because we did not connect it to any database of the sort. So they're all lost once we like reload the page.
Mhm.
Yeah.
Yeah, we can. I think I should probably expand the app.
Probably
Um,
not. Maybe you wanna
Okay,
go
so
over this?
I'd like to like just quickly go over like how to expand the application. I know we couldn't completely finish it, but that'll be like the last part of this this workshop. And again, we'll post more instructions and how to set up the Firebase and Firestore and all that. So I'm just gonna quickly go over. I basically wanted to talk about when you're expanding your application, you have like a bunch of decisions to make, especially when it comes to new features. And the two like really modern approaches to expanding an application is either you go the monolithic route or the microservices route. And this is especially important when you're using stuff like Google Cloud and AWS and cloud computing in general. Monolithic is basically, it's kind of hard to see, but you have everything in like one package. And whenever you have a new feature that you want to add, you kind of build on top of that package, that code. It's kind of called like growing tall. And then in microservices, it's completely the opposite. You grow wide. You have a bunch of different features that each within themselves are like a microservice. And they kind of communicate with each other in order to create the final product. So I wanted to go over like a quick thought experiment into how would you, like one of the things that we're missing right now from our application is, although you can add as many rooms as you like physically in the code, you can't really like allow a new user. We're not allowing new users to like create new hubs or create new rooms. We're kind of doing that for them. We hard coded this. So I wanted to give like a quick thought into how would you make a new feature or add a new feature, and let's call it like the orchestrator. And it's its own object again, and it takes care of creating rooms, adding rooms, and checking if the room exists. So I wanted to just quickly go over it. If say we wanted to do it the monolithic way, just put it into our application, like just directly add it to the code that we have, rather than making it its own service. And basically what we're going to do is imagine that you're using Google Cloud or AWS. You can't really see it, but to scale your application, what it's going to do in the background is really important for you to understand, so that like you can use that to your advantage. And let's say that we create our own instance of this application. We call it Chatty, and there's just a single instance that you have, and it's in Florida for whatever reason. And then you have a bunch of blue dots that are like user groups that are using your app. So your app is like expanding and there's a bunch of new users using it. What's going to end up happening at some point is this one instance is going to get overloaded, and you're going to need like sort of to handle all these users. So what these like cloud computing services do is they just say, okay, I'm just going to spin up a new instance and I'm going to put it somewhere that it's nicely located. And that's it. You're like, it's a good problem to have. You have a lot of users. It needs to scale. Like, that's amazing. But then you run into another problem, which is there's more blue dots popping around, and they're like, you start getting more and more users. So this comes into how you want to think about like scaling and how your app is going to get really big from the very beginning. because now it's going to get stressed again. So like, okay, you've been through this, you want to add another instance. Awesome. So, but then again, there's more users popping up and then your instances get overloaded. But you're going to run into a point, and remember, each of these instances have both the orchestrator and the chat application that we just made. What's going to happen is you're going to start realizing, like when you look at your cost breakdown, say you have a budget and it's exactly 3 instances and you're like, what's going on? Why am I like spending so much money on keeping these 3 instances alive? And especially like why you're always going to have like competitors to an app that's successful. Why are they able to do it like cheaply and more effectively? And basically say you take a look at each of these instances like individually and you're like, you start with North America and you're like, where's the stress going? And you see that most of the stress is going to the chat application and not to the orchestrator for whatever reason. And then you look at Europe and it's like the same thing. And then when you look at it, it's like really intuitive, right? People are chatting way more than they're creating new channels. Like that's kind of what a chat application is all about. So basically these 2 features are getting like a very unleveled level of stress or attention. And so you kind of have a theory and you're like, okay, that sounds good. And then you go to Asia, for instance, and it's like, you know, who messed up the PowerPoint slide? But no, like this can totally happen. So I just wanted to throw that in there because like something might happen when you least expect it, but this is totally plausible. You can have a lot of new users create servers and accounts, and then they're like, this sucks, I'm just going to use Discord. And so they don't chat as much, and it's kind of like, so basically the takeaway from this is, imagine instead of doing it monolithically, you turn it into a microservice, and you split those off into only the instances that you need. Now, using the power of cloud computing and spinning new instances and how you design your application just from the very beginning, you're saving a bunch on your budget. And it's like, this is a very simplistic example, but I was just hoping to introduce you to those concepts, monolithic and microservices, and how usually when it comes to cloud computing and scaling, microservices comes in really handy, splitting everything off into little instances. Yeah, that's it. So remember to check in if you haven't. It helps us with UCF. And leave any feedback for the event, good and bad. And there's the source code again. Thank you, guys. Okay. Yeah.
When you're like, scaling it horizontal scaling,
Yeah,
basically people and not.
it could be. Yeah, a lot of non-SQLs use like wide.
Because that's the reason why I feel like NoSQL, like, you use NoSQL because like scaling to websites, users sign on.
Yeah.
That's why you know question SQL when it comes to like big just mass data is coming in.
Yeah.
Okay, that's what I like. Made sense when you rewrite the last line. I really makes sense. Kind of easy.
Thank you.
That's unfortunately we ran out of time. I think
Yeah.
I want to go.
I mean, some.
Yeah.
Thank you for coming.